Hello, this is Matt Danielson, and I'm going to be demonstrating the Wireshark lab with the IP protocol for CS457. So what I have over here on the left is Wireshark ready to go. On the right I have the program ping plotter, which will allow me to send the ICMP messages to the routers. My destination is going to be the example gaia.cs.umass.edu. If I look at my options, my packet size that I will be sending is 56 bytes initially. So if I go ahead and start capturing these packets, I'll start a new Wireshark capture. And then I'll start my ICMP messages. Let that run for a second. I'll go ahead and change the packet size. Change this to 2000. Have it go a couple more. Then I can go change this to 3500 and have it run a few more, changing the packet size. So now I can stop my Wireshark capture. I'm filtering right now on ICMP. So if I go to the top, okay, so the first question is, look at the first ICMP package and see what my IP address is. So that's going to be this one right here. And my IP address for source is going to be 192.168.0.14. And this is the destination, which is the Gaia server. The protocol, if I look at this tab here, is going to be ICMP. And then if I want to know how many bytes are in the payload, I can look right here at total length. So there's 56 total bytes, and the header length is 20 bytes. I can know if it's fragmented or not by looking at where it says flags here. I can see there's a more fragments and it's not set, which means this is not fragmented. And then again, question number 3, how many bytes are in the payload? That would be 36. 56 minus 20 for the header. Okay, the fields that always change from one to the next is the identification, the checksum, and the time to live. The time to live will increase by 1 for each router that is going ahead. And then I can see that by looking at the next packets here. If I look, the time to live is going to increase, and the checksum and the identification will also increase by 1. And the checksum will change, but the identification will change by 1. Yep, so these values, they are not unchanged per, or they are the same for each first hop router, except for the identification, because it's going to be sending a new one each time, but the time to live will be the same every time it sends it to the first hop router. Okay, so now I want to look and see when the packet size got changed to 2000. So if I sort by length, if I look here, this is the first packet that was sent with the byte size of 2000. So if I look here, the header is still 20 bytes. And actually I'm going to want to take off the filter here. So let's look at number 218 here. This is the first one. It's number 218, and 219 is the finish of it. So the length of this first packet is going to be 1500 with 20 bytes. I can see that it's ICMP protocol, and I can see that it's been fragmented because this more fragment bits or more fragments flag is set to 1. Then if I keep looking, I can see, let's see, if I look at the next packet here, I can see that it's been created out of 2 IPv4 fragments. That was numbers 218 and 219. So the first one was 20 bytes for the header plus 1480, and the second packet was 500 bytes. So that gives a total of 2000. And then if I look at the second one again, I can see that the more fragments bit is not set. So that means that's the last fragment in the package. So the fields that change between the first and second fragment, the identification will not change, but the flags will change, the length will change, and that should be it. Oh, no, yeah. So then if I look at a one that has 3500 for the bits, just come down here towards the bottom. If I look at this one, for example, this one is the first out of a set of 3. You can see that by this one saying that there's 3 IPv4 fragments, number 693, 694, and 695. So 693 was the first in this series of 3500 byte packet. And then this one has the more fragments bit set. 694 was the second one. This still has it set. And both of these had a total length of 1500. And the last one, which was 695, has a length of 540. And then this one does not have the more fragment bit set, and which was 0. And also the fragment offset will change between each of the packets, with the first one having an offset of 0. So that demonstrates the ICMP/IP lab for CS457 Wireshark lab. Thank you.